This comes from lesson 2.7, and it says to solve this inequality. Enter your answer using interval notation. So here's our inequality. And in order to solve the inequality, what we'll need to do is we'll need to try to factor this. So when I factor, the greatest common factor among the two terms on the left side is x. So I can factor out an x, and then I can look at this portion here, and I can see, can I factor this? Yes, I can, because this is a difference of squares. I can say x minus 5 and x plus 5. So now that I've factored this inequality, I want to find what are called the key numbers. So the key numbers are the test intervals. And, well, we'll give you the endpoints of the test intervals is what I should say. And so to find that, think of this as if it was a polynomial equation, and I wanted to solve for x. So I'll set each of these equal to 0 and solve for x. So, and that will give me the key numbers. So I get x equals 5 here, and I get x equals negative 5. Plus I have this x equals 0. So here are my key numbers. And so let's look at those on a number line. So on a number line, I will have to test this fraction. I will have to test between these two key numbers. I'll have to test between these two key numbers, and I will have to test in this direction. And I'm going to see in each test interval, I'm going to choose an x value and see and evaluate whether I get a positive or negative number. So I want to pick values in between each interval. And what I'm going to do is I'm going to make a little chart. And so I will have the test interval from negative infinity to negative 5. And notice I don't have to include the negative 5. I'm just doing the interval portions right now. Then from negative 5 to 0, from 0 to 5, and from 5 to positive infinity. So this is the interval. Then you are going to pick your test point, and then you're going to evaluate, and you're going to decide whether it's positive or negative. And let me put our polynomial back over here. So I'm going to pick some test points. So negative 10, let's do 1, let's do negative 1 in here, and let's do positive 10. So negative 10 cubed will give me negative and negative 1000 minus negative 250. And we'll end up with negative 750. So this will give me a negative value. And then I do the same thing for each one. So negative 1 cubed minus 25 times negative 1. And so evaluating that. So I'm going to go through and I'm going to evaluate these. So here I'll get negative 1 plus 25 or 24. Here I will get 1 minus 25 or negative 24. And last, I am going to get a positive 750. And so my original interval, or my original inequality, was x cubed minus 25 is greater than or equal to 0. So we want to know when it is greater than or equal to 0. And that is, in this case, I'm looking for when it's positive. So then I'll have two answers. This will be 1, and this will be 1. And because my symbol was greater than or equal to, it's going to include the endpoints. So if I was drawing this on a number line, then my answer would look like this. And I would say negative 5 to 0, and then 5 to infinity. So you can use the bracket symbols, or you can use the, if you're drawing it by hand, some books use a closed dot. Our book and WebAssign uses the bracket symbols. So this is how it would look. And so that's our answer. Written in interval notation, you would say negative 5 to 0 and 5 to infinity. These all have brackets because of that greater than or equal to sign, because it includes the endpoints. Infinity never has a bracket. It's always open-ended. And then you'd want to put a U for union. So this is a shorthand for a union. It involves the solution for all of this.